So we've been working on coming up with a novel synthetic viscous supplement that is truly chondroprotective. And what I'm going to present to you is some of our proof of principle. These are our disclosures and our acknowledgments. So as we all know, osteoarthritis is a chronic, non-inflammatory arthritis that affects articular cartilage. There's progressive breakdown. It has a complex etiology. It can be genetic, it can be mechanical, it can be congenital. But it's a leading cause of disability, and it affects 13% of the world's population, 27 million in the US alone, and it's expensive. So, healthy articular cartilage, as Henry Mencken used to say, it's nearly frictionless. It's the coefficient of friction of ice on ice. But in OA, what happens is there's decreased lubricity of the synovial fluid, and this starts becoming a wear problem. There's increased cartilage wear. And what happens is there's a shift in the lubrication process of the cartilage. It goes from elastohydrodynamic lubrication, which is sort of like cartilage is like a sponge, and if you squeeze a little bit of water comes out and you have a fluid film. And it shifts to something called boundary lubrication, which is more like oils in the piston of your car. It's just a coating. And the reason this happens is in early arthritis, you lose the glucosaminoglycans. Those are the aggregates, the fixed negative charge density that holds water in cartilage. And when that breaks down, you have increased permeability, increased transport of water, and less interstitial fluid pressure. So what ends up happening is you have an increasing coefficient of friction because you can't lubricate the cartilage as well, and there's increased wear. And this is particularly problematic in these activities that Eric Radin actually calls stiction. It's like when you've been sitting for a while and you first get up, that's sort of that first instance where you actually, there's an increased friction at the cartilage surface. So what happens is synovial fluid degrades in osteoarthritis, and in particular, it affects the hyaluronic acid component of the synovial fluid, and this is key to hydrodynamic lubrication. Now, there's other important lubricating molecules, lubricant, of what Matt has been working on, and then surface active phospholipid, that are important in boundary lubrication. These are relatively preserved in osteoarthritis, but it's the hyaluronic acid in the synovial fluid that's markedly decreased. So the treatments, basically, in early stage, we use over-the-counter drugs, ibuprofen, aspirin. As we start getting into mid to early stage, we start increasing to COX-2 inhibitors, maybe microfracture, and then sort of in this grade 3, the mid to the late stages, which Martha was showing after the ACL replacement, is potentially where these viscous supplements, and currently what's approved is Synovisc, which is an HA hyaluronic-based additive to the synovial fluid, corticosteroid injections. You can have autologous chondrocyte transplantation or Oates procedures, and then ultimately end up with total joint replacement. Now, viscous supplementation came about probably about 15 years ago, and the idea was, if I supplement the hyaluronic deficient OA synovial fluid, I can somehow improve the articular cartilage lubricity. But then when you started looking at the ROC, the randomized control studies, a meta-analysis of all these studies basically said that it was only 8% better than placebo. And that's because hyaluronic acid is degraded by hyaluronidase, which is the enzyme in the synovial fluid, so you have a very short resident time in the joint. So my collaborators, Mark Grindstaff over at BU, and I sort of came up with this idea, and he's the biochemist, so he actually came up with the chemistry. But basically, this is a norbornene polymer, which is synthesized via this ring opening metathesis polymerization. And what we do is you have these tetraethylene glycol chains, which basically help improve the biocompatibility. The polymers dissolve in deionized water, and basically we call it 2-MTEG because the molecular weight of 2 megadaltons helps retard diffusion from the joint space. And importantly, it's because of this carbon-carbon bond that it's not degradable by hyaluronidase. So the target design was to improve the intra-articular residence time. So this is what typically an HA viscous supplement looks like. And it's this glycosidic linkage that's degraded by hyaluronidase, so its joint residence time is only a couple days. The TEG polymer actually has a carbon-carbon linkage, so it's very slowly degraded in the joint, and in our early studies, we found that 75% of the injected polymer was in the joint at 11 days, and we had an estimated half-life of 20 days. The other target design was to create a viscous lubricant so that the mechanical properties mimic that of normal synovial fluid. So what you want is cushioning at high impact jumping loads, but then flow and lubrication at low impact walking. So when you have a higher stored modulus, it's stiffer, and that sort of represents the ball shape at the very top. When you have a higher loss modulus, basically you're absorbing energy. And so what you want to do is create something that sort of has this mix. So if you look at normal human synovial fluid, its storage modulus is around 23, its loss modulus is 7. Now Synovisc is very, very stiff. You see it's almost an order of magnitude greater than what normal synovial fluid is, and we tried to design this polymer so it was more like synovial fluid. It's more biomimetic. So we did standard tribologic testing, which is basically you're looking at the coefficient of friction. And the 2% concentration by weight performed better than saline, Synovisc 1, so Synovisc 1 is the Genzyme product that's on the market, and bovine synovial fluid. If we do prolonged torsion friction tests, we see that there's significant improvement in the frictional performance for the 2M TEG compared to saline and to actually bovine synovial fluid. So our hypothesis was that 2M TEG functions as a viscous lubricant with better lubricity than bovine synovial fluid or Synovisc. That the 2M TEG reduces friction of worn cartilage specimens because we're going to be injecting this in somebody who already has arthritis, and it performs that better than synovial fluid or current HA supplements, and that the TEG is biocompatible. So what we're doing is we're evaluating the viscous lubrication, and baseline, this is a sort of standard test. So we have a bovine osteochondral plug, we have a patella, and then matching femoral groove, we have a plug. We're going to do a torsion test. And then what we do is this series of tests where we soak it in saline, put it in our lubricant, and then we do basically greater than 10,000 cycles at 360 degrees clockwise and 360 counterclockwise to basically wear this out. And then what we looked at is, so we did an initial preconditioning in bovine synovial fluid, then we did the first wear test in synovial fluid, then the 2M TEG, then back again in the bovine synovial fluid. And if we look, we see that if we compare wear 1 to wear 2, the plugs tested in the 2M TEG, the coefficient of friction was reduced by about 21% versus the bovine synovial fluid. So basically, it does better than synovial fluid in worn specimen. We wash it out, we put it back in the synovial fluid, and now the coefficient of friction increased by 26% versus the wear 2, and overall 2% versus wear 1. And what this means is that 2M TEG has no residual lubricating effect. So in other words, it's not working as a boundary lubricant. It's actually, it's working with the fluid itself. And then what we did is this next test is we said, okay, let's really wear out these specimens. So it's the same protocol, but we do a wear 1 and a wear 2. So basically 20,000 cycles in saline, and then we compared synovial fluid to the 2M TEG. And then we did is looked at the surface roughness and the total number of wear rings. And I'm not sure how well it projects, but this is almost like rings in the tree. You can actually see the wear pattern. And this is sort of what Martha was showing you in those pig studies where you sort of saw the cartilage worn out. So this is a single plug pair just to give you an example. So you see that there's a slight increase between 10,000 and 20,000 torsion cycles. But then when we do the 2M TEG, we reduce the coefficient of friction substantially. And in fact, if we compare bovine synovial fluid, Synovisc, and the 2M TEG, we see that it lubricates better. In other words, it reduces the coefficient friction more than the synovial fluid or the Synovisc. Now, if we actually look at the surface roughness, and those are the red bars, and the total number of wear rings, which are the blue bars, which are basically evidence of wear, we can see that the 2M TEG performed better than saline and synovial fluid in terms of the total number of wear rings, and better than saline for the surface roughness. So then the next step is we did the standard tests of biocompatibility to prove that there was no cytotoxicity, genotoxicity, that it was hypoallergenic, and it passed all those standard tests that you're required by the FDA. And then we were ready to try an animal study, so we started out with the rat meniscal tear OA model. This is a standard model. We used male Lewis rats. It's a medial collateral ligament transection, then a full thickness cut in the medial meniscus to simulate a complete tear. And then we did single intra-articular injection 1 week after surgery, and we had either saline, Synovisc, TEG at 0.25%, and then at 1%, and then the animals were sacrificed at 3 weeks. And then basically we did the standard histologic analysis, and there's various scores, and we just followed systematic protocols, and it was evaluated by a board-certified veterinary pathologist who was blinded as to actually the groups. And what we found is the Synovisc versus the saline, there's no difference, but the 2M TEG versus the saline, there was significantly less cartilage degradation. So basically, it looks like the 2M TEG functions as a viscous lubricant with better lubricity than bovine synovial fluid. It reduces the coefficient after initial wear tests, and then basically it looks like it's not staying on the cartilage, because when you wash it out and retest it in bovine synovial fluid, you get back the original properties. It's demonstrated significant reductions in the coefficient of friction in worn cartilage specimens, and that's really where this stuff's going to be used. It's going to be somebody who already has degenerative changes. Our biocompatibility and cytotoxic studies are negative, and basically, at least in this very early in vivo rat model, we've proven chondroprotection. So our future studies are now to actually look at some ex vivo human OA cartilage, and then we'll use a large animal model similar to what Martha's done with ACL transection to evaluate in vivo performance. So basically, the 2M TEG lubricates better than synovial fluid or Synovisc, and we think that we could use this to augment the osteoarthritic synovial fluid, and it appears that it functions as a viscous lubricant. And by reducing the coefficient of friction for worn cartilage, we think we could mitigate further cartilage wear and ameliorate the progression of OA. Thank you very much.